In this video, we're going to look at a typical word problem that you could encounter, say, in an algebra class. We're going to analyze the problem, set it up, look at a procedure. Now, the procedure I'm going to look at pretty much follows the strategies given by George Poya. But let's read the problem first. That's going to be actually look at the first few steps of the procedure. We want to read the problem, of course. So we have Bill and Jim leave from the same location and travel the same route at a constant speed. Jim's driving speed is 60 miles per hour and Bill's is 63 miles per hour. If Jim leaves 45 minutes before Bill, how long would it take Bill to catch up? Okay, so Bill's going a little faster, so eventually he's going to catch up. How long is it going to take? Okay, so you want to read the problem. And of course, you want to understand it. Understand what they're asking you. Because if you don't, you won't be able to solve it. Some of these problems, your instructor might want you to set up an equation. Typically, it's what they want. So you pretty much have to follow a standard procedure. So you want to identify a formula that can be used if possible. Okay? Formulas you can, the standard, say the formula for a triangle, area of a triangle or a circle, perimeter and so forth. Identify the unknown. So in this case, it says how long will it take Bill to catch up? So we're looking for time. Okay? And since speeds are given here in miles per hour, then the time we want it converted to hours. Okay, we want all the units to be consistent. So the 45 minutes here converted to hours, since there's 60 minutes in an hour. This reduces down to 3/4 of an hour. Okay, so kind of write everything down, put a description for those quantities, so that could help you set up the problem. If possible, draw a diagram. Okay. And then typically, if you want to set up an equation, we want to identify two quantities, and we want at least one of these quantities to have involve the variable, whatever you want to call it, t for time or x, it doesn't really matter. And if you can find two quantities that are equal, you can set them equal, and then it's just a matter of solving the equation. Set up the equation, solve it, and then check your answer. Okay. Some cases you might do a trial and error to see if you can get an approximation for your answer, and then verify it with the formula. So obviously here we're dealing with distance, we're dealing with rates. So one formula that comes out here is the distance formula. Distance is equal to rate times the time. Okay. So this tells me if you know your speed and you know the time, you can find the distance. So if I'm going 50 miles per hour, I travel for, say, 2 hours. Hours cancel out, and then 2 times 50 gives me 100. So I know that the distance traveled in 2 hours is going to be 100 miles. Okay. Now in some cases, I might want to find the rate or the speed. So solving this equation for r, I get r is equal to distance divided by time. Okay. Or solving for t, t is equal to distance divided by the rate. Okay, so you have different options here. Okay, so again, you got to look at the problem and then write down the information and see what you can come up with. So pick a variable. I'm going to pick t for time. You can use x, it doesn't really matter. And I'm going to let t equal to the time required for Bill to catch up. Time required for Bill to catch up. Okay. So Jim has a 45-minute or 3/4 of an hour head start. Okay. So at the time that Bill takes off, Jim's already been gone for 3/4 of an hour. Okay. So if t represents the time required for Bill to catch up, at the point when Bill catches up, t plus 3/4 will be Jim's time of travel. Okay, so we can set up a diagram. Okay, so let's suppose we're looking at this. So here we are. Let's say they both start at point A, right here. So Jim starts off first, so he takes off. Okay, so he's got a 45-minute or 3/4 of an hour head start, so he takes off. And then let's say right there at point B is the time where, at the point where, so point B will be the point where Bill catches up. Okay, so at that particular point then, since we let t equal to the time required for Bill to catch up, then Jim's been traveled already for t plus 3/4 for 45 minutes. Okay, because he had a 45-minute head start. So speed times time gives me distance. Okay, so this is the distance traveled by Jim at the point where Bill catches up. And up here, since Bill's going 63 miles per hour and t represents the time that he traveled to catch up, the speed times the time is his distance. Okay, but remember, they started at the same point. They went through the same route. So the distance covered by both has to be equal. Okay? And of course here we're assuming, again, as the problem said, a constant speed. Okay, so let's assume they're on the highway. There's no stoplights or stop signs and so forth. So it's a constant speed. So then we can make the statement that it has to be true then that 63 times t, okay, except that's the distance that Bill covers to catch up, and that has to equal to the same distance that Jim travels. So this is going to be 60 times t plus 3/4 of an hour. Okay, because he had a 45 or 3/4 of an hour head start. So then to solve the problem, we just have to solve this. So let's go ahead and say this is going to be 63t here. And then on the right side, multiply through by 60. This will give me 60t. And 60 times 3/4. Multiply and divide that out. This is going to be 45. So solving here for t, subtract 60t from both sides. This will give me 3t over here. Equals to 45. Divide by 3. And we get the time required for Bill to catch up is 45 over 3, which is 15 hours. Okay, So this is setting up the equation to solve. And again, some of these problems, especially if the answer is an integer or a whole number, you can do a trial and error. But if the answer is, say, a decimal, say it comes out to 14.1 or 14.36, so a little bit harder to do a trial and error. It might take you longer, quite a bit longer. But this is the way you would do it if you have to set up an equation. Now, we can check this, and you always want to do that. Does your answer make sense, and can you check it? So in this case, then, let's see, 63. Let's compute the distance traveled by Bill, 63, and then the time, his time supposedly is 15. Okay, so this would be times 15. So from the start to the point where he catches up, he goes 945 miles. Now let's do Jim. 60. And then I just put this in parentheses, and the time is t plus 3/4. So this is t is 15 plus 3/4. Hit enter, and we get 945. Okay, so that's a check that the distances are the same when t is equal to 15 hours, and one has a 45-minute head start. That's how long it would take to catch up. Okay, so this is just one technique that you can use, and again, not everything applies. Sometimes it's a little bit difficult to draw a diagram, but anytime you can. This one is a problem where it really makes it easier. You can see it clearer if you draw yourself a diagram. Okay, so this will be it for the video. Thanks for watching. We'll see you next time.